Let's take a look at what it means for one complex number a to be multiplied by the complex conjugate of another complex number b. Okay, so here we're going to assume that a and b are both complex. Okay, so we're going to try to get some intuition into what is going on here. So first of all, let me start off with a heuristic definition. And what I'll define is the concept of how similar are two complex numbers to each other. And what I'll say is that these two numbers are similar if a and b lie on top of each other. Okay, and of course I will be referring to the complex plane when I'm talking about lying on top of each other. And that's supposing a is this complex number, and then b is another complex number that is basically exactly the same as a, then I would say that a and b are very similar in this case because they're lying right on top of each other in the complex plane. Okay, so similarly, let me define another heuristic definition here to say that they're not similar if those complex numbers are orthogonal to each other. Okay, so then if let's change the b here. So b is no longer the same as a, but it's actually a complex number that is orthogonal to a, with this being 90 degrees, then I would say that a and b in this case are definitely not similar to each other. So the question then is if we can derive some sort of a metric that will give us an indication of how similar or not similar two numbers are to each other. And so let's start off with a candidate being just the simple product of these two complex numbers. Okay, and let's suppose that if we take the real part of this simple product, then that will give us an indication of how similar these two are. But if we take the imaginary part of the product, then that will tell us how not similar those two numbers are. Okay, let's see if this is a reasonable assumption. Suppose we have a and b both be equal to some complex number of modulus 1, and then also suppose that the theta in this case happens to be 45 degrees. If we were to plot this out in the complex plane, what that would look like is a and b, supposing this is 45 degrees, a and b would be right on top of each other. Okay, so if you were to take the straight product, then you would see that that's going to be e equals e to the 2j theta, and in this case it's just going to be 45 degrees plus 45 degrees, which is going to give you just j by itself. Okay, so the real part of AB in this case would mean we want to take the real part of j, but that's going to give us 0. Okay, which then tells us that according to our rule, these two complex numbers a and b are not similar to each other because their real part is 0. Okay, that's clearly not good news for this metric because in fact you expect the opposite, because a and b are in fact the same complex number, so you expect that they are very similar by our heuristic definition. But this chain of reasoning using this AB as the metric actually ends up giving us the false reasoning, or I should say false result. Okay, so let's see if we can then modify this metric to give us something better. And so clearly, if we look at the complex plane again, we can see that if a is in fact 45 degrees, then the right thing to do is really not to multiply by b, but to actually, because multiplying by b would just add another 45 degrees on top of it, and we don't want to do that. What we want to do is to actually subtract 45 degrees from a. Okay, and so what we should do is to reflect the b about the real axis, and that results in getting the complex conjugate of b. Okay, so in this case then, a is going to be equal to j theta as before, b is also equal to j theta, but instead of taking the straight product, we're going to take a times b conjugate. Okay, so that's going to end up giving the desirable property of making this a minus sign, the angle on b a minus sign. In this case then what's going to happen is the result is going to be 1. And so the real part of AB star then is now 1. And the imaginary part of AB star is 0. So this is really a much better, is much more consistent with our heuristic notion that we laid out here, right? Because now you have two complex numbers that are very similar to each other, and then when you perform the sort of a special multiplication on these two numbers, then the real part of that special multiplication gives you an indication of how similar they are, while the imaginary part of this kind of special multiplication gives you 0, which is telling you that the not similar part is actually 0, which means then that these numbers are similar. So then the rule that we end up with in the end is that if you take the real part of A times B complex conjugate, then that tells you how similar A, B are to each other. And if you take the imaginary part, then that would give you how not similar. And so this is exactly the metric that we were looking for in the beginning.